All right, 2-7, systems of quadratic function. This is the last section of quadratics, which means that you will have a review and test coming up. So let's get to it. This one should be much shorter than a quadratic formula because we have our wonderful tool called Desmos. So for our first example, when we dive right in, it says determine the number of real solutions. So for example 1, it's actually asking you how many times do the functions intersect? Okay, so I have 3x squared and I have 3x minus 2. All right, so in this particular example, notice they will never cross. No matter how far I zoom out, they are not crossing. They're not touching. So this particular example is 0 real solutions because they never cross. If we think about the possible types there could be, I could have a graph of a quadratic and a line that touches twice. I could have one where they touch once. Or in this case, we had it where they never touch. So my possible types of answers are 2 real, 1 real, or 0 real, which would mean that they would have imaginary. So recall that from the discriminant in the last section. Okay, moving right along. So that was a quick one. That's all it wanted. It just wanted to know how many, not what are they. In this case, in example 2, they actually want you to solve it. It says by substitution. We're going to cross that out. We're going to use Desmos. We would only want to use substitution if we had no access to a calculator, but we do. So we are actually going to solve this in Desmos. So flip over to Desmos here, erase what's in there. And I have y equals 2x squared minus 6x minus 8. Here's why I love Desmos over anything else, is I no longer have to get y by itself like your Algebra 1 teachers made you. Because Desmos will graph it without y by itself. Then I want to figure out where they intersect. Notice they only intersect once. They intersect at 2, negative 12. And that's my answer. That easy. If I wanted to check my answer, I could plug this in for x, plug this in for y, and make sure I get true statements for both of those things. All right. What if it's an inequality? So inequality, it's going to be the same idea. I'm going to type these into Desmos. Erase what's there. At any time, I would always be following along. And if you get, like if I get ahead of you, like I'm working too fast, there's always the rewind button or the pause button. Take full advantage of that. All right, so here's what my graph looks like. My graph that I used is terrible because this one goes way down. Okay, so have a vertex at negative 321. So maybe I want to know those points to sketch a rough picture. For the blue one, I want to know any of the other points that it gives me. it's helpful. And then I want to sketch the picture the best I can. Now, my numbers are off, obviously. So what if I made these count by 2s instead of 1? So that would be -4. Hold on, try that again. All right. So this will be 4, 6, 8, 10. Did it again. Math is hard today, you guys. 8, 10, 12. There we go. 16, 18, 20, and those are all negative. And then I'm going to go the same way up. Okay, now I should have enough. I know that 0, 8 is going to be one of my points for my line. -2 and 2/3, so like right here. If you recall, it was a solid line. So in a moment, I'll go back to Desmos to remind you it was solid when my red parabola was actually dashed. So using some of the points here, it had dashed. It was red, but it's okay to use the same color. Not all of us have all the different colors. And then the part I want to pay attention to is where do they overlap? So where does the blue overlap the red? Notice it is in the middle. That's not always the case. I could have a question where this sign changes. And notice there's a different shading if the sign changes. So pay attention to your signs. They are important. But in this case, the part that they overlap in is the part that I want to shade. And notice I'm only shading the overlap. I'm not shading all of the rest of it, just the overlap. So when I'm solving a system, just the overlap is the answer. Okay? So just a reminder there. All right, one more question. We are finished. Actually, hold on. Let's make a couple of notes about this last one. So less than or greater than are dashed lines. So if there's no equal to symbol, it will be dashed. If it is equal to, so if there's a solid line underneath, it is a solid line. If you still have trouble with what's less than and what's greater than, less than makes the L for the word less. Greater than makes the wing for the capital G in greater than. Okay, so just to help you out on some little brief notes there. All right, so we can also use a system to solve an equation. So this goes back to 1-5. We're going to do this over and over and over again. We're going to put the left side in Y1. We're going to put the right side in Y2, meaning the second line. And then we're going to find out where they intersect. And wherever they intersect, the x value is what it equals. So let's try that out on Desmos. 3x squared minus 7x plus 4. 9 minus 2x. So notice I have a parabola and a line. Also notice that they cross not once, but twice. And they cross at decimals, and you know, decimals aren't our favorite, but hey, at least it's just a decimal. No big deal. We only care about the x values. So we only care about negative 0.703 and 2.37. We do not care about the 10 or the 4. Okay. So to wrap up our notes, our final answers here, let's use a pen, not a highlighter, is x is approximately, remember a wavy equal sign is approximately, so I don't have to spell out that big old long word, negative 0.703 and 2.37. And that's it. We're done. We have solved for x by graphing, which is much easier than having to set equal to 0 and do the quadratic formula. So we could use this option instead. We have now wrapped up the unit. Complete your target and be on the lookout for a review.